Welcome back to another lecture on graphs of trigonometric functions. We are going to discuss sinusoidal functions. What are these functions? When you have a y equals sine x, that is a trigonometric function, a very basic, simple trigonometric function. And just like any other function, you can always construct a table of values. And you can select values of x, such as 0 degrees, or 0 radian, pi over 6 radian, or 30 degrees, or pi over 4 radian, or 45 degrees, and so on and so forth. You can select different x values, and you can calculate the value of a sine of those angles using your calculator. When you write those numbers down here, for example, sine of a 30-degree angle or sine of pi over 6 radian is 0.5. Sine of pi over 4 radian is 0.707, rounded to 0.71. Sine of pi over 3 radian is about 0.86, and so on and so forth. When you plot these points, on a set of coordinates, you end up with a whole bunch of points that when you plot these points and you draw a smooth curve passing through these points, you end up with a wave-shaped kind of graph, which we call it sinusoidal graph. Okay, sinusoidal means wave-shaped kind of curve. So this is the graph of sine of x, a simple trigonometric function that we obtain by just constructing a table of values. And the thing is that if you keep going, and when you reach 2 pi, if you continue, and instead of 360 degrees, for example, you punch in sine of 390 degrees, because you are entering into the territory of coterminal angles, and we have talked about it in the past, so you end up with the same answer over and over again. For example, you know that if you have 30 degrees and you add 360, that's going to become 390 degrees, which is a coterminal angle with the principal angle of 30 degrees. And coterminal angles are angles that share the same terminal arm. So if you draw the diagram for the angle inside the position, they're going to be exactly same terminal arm, same initial arm. So if you find sine of 390 degrees, if you continue in this table of values and select more, like greater and greater values for x, such as 390, you punch in sine of 390, you see that you get again 0.5. Same answer you got from sine of 30 degrees, that is pi over 6 radian. So we see that the same trend keeps repeating over and over again, and that is why the same shape will keep repeating itself. And it doesn't matter if you add 360 with 30 degrees to obtain 390 degrees, or if you subtract 360 from 30. So you go 30 minus 360, which is negative 330 degrees. And when you punch in sine of negative 330 degrees on the calculator, you will see 0.5 again. So negative 336 is right almost here, and you see that it's going to be the same y value of 0.5. So we see that on the right-hand side of the y-axis, on the left-hand side of the y-axis, this shape, we call it a cycle, keeps repeating over and over again towards positive infinity. How many times does this repeat itself? 10 times, 20 times? No, infinite number of times. Is it true that the graph starts from negative infinity and it stretches towards positive infinity? Yes, it is true. Is it unlimited and never ending from both ends? Yes, that's also true. So we are studying only one cycle of this trigonometric function, y equals sine x. So from here to here, from 0 to 2 pi, is actually one cycle. Then from 2 pi to 4 pi would be the second cycle. So these are all cycles that you can see the shape repeats itself, okay? These are 3 cycles of sine function I have graphed here. Now, you may notice that there is a point that is called the highest point or the maximum point on the wave-shaped curve. It is also known as crest. So that maximum point, the distance between the maximum point and the x-axis, which is known as axis of the curve, that distance has a name. Okay, we call it amplitude. So amplitude here is actually 1. Okay, Amplitude is a distance. It's always a positive value. It's the distance between the axis of the curve, or this axis, x-axis, which passes through the heart of the graph, up to the maximum point right there. This is the maximum point. You can also say the minimum point, the lowest point on the graph, and the x-axis, they also have the same distance because of absolute symmetry the graph has. So the amplitude is the distance between the x-axis and the maximum point, or x-axis and the minimum point. And the amplitude is 1 unit. Now, the length of one cycle is called the period, and it is 2 pi. So, definition of period, write it down. The length of one cycle. How many units is it? From here it starts all the way to 2 pi, and then it repeats itself another 2 pi units. So that is the period. Maximum value is right there at the top. It's positive 1. Minimum value is at the bottom. And when we say value, we mean the y value, obviously. Equation of axis of the curve is just equation of x-axis, whose equation is y equals 0. So y equals 0 is the equation of axis of the curve. Domain of the function, we have no restriction on selecting the x value. X can be any angle, even negative angles. So the domain here, I'm going to say, is the set of real numbers. Any angle you want, you can select. Even on your calculator, you can punch in sine, and then any angle you want, 20 degrees, negative 200 degrees, whatever you want, you can punch it in. You will never get error message or syntax error on the screen of your calculator. Range of the function. So here, you may notice that the maximum value was just 1. So we have an upper limit here, and the graph never goes beyond that, apparently. So the maximum value is actually 1. And the minimum value is also negative 1. And we see no part of the graph is below the minimum point. So this is the horizontal line, y equals negative 1. This is the vertical line, y equals positive 1. So the graph always fluctuates between its maximum value and minimum value. So this means that the range of the function is all real numbers between 1 and negative 1 inclusive. So I'm going to write down here y belongs to set of real numbers such that y is between 1 and negative 1 inclusive. So that is the range. You can also write it in the interval notation with square brackets, negative 1 comma 1. Domain in interval notation would be negative infinity, positive infinity, open interval. So these are all the properties of sine function. And x-intercept, well, it happens at 1 pi, and then 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, 10 million pi, and here negative 1 pi, negative 2 pi. So generally speaking, the x-intercept is actually at k pi, all right? And k is just an integer, 0 plus minus 1, plus minus 2, plus minus 3, dot, dot, dot. It could be 5 pi, 6 pi, 7 pi, so on and so forth. That's the x-intercept of the sine function. There's like 5 or 10 x-intercepts, so don't expect me to write 5 or 10 numbers. There's like millions of infinite number of x-intercepts, does exist out there. So don't expect me to write like a couple of x-intercepts. That is why I'm writing a formula, x equals k pi, that generates all these x-intercepts for different values of k. You understand? Y-intercept is, of course, 0. Needless to say, the graph passes through the origin. Now, if you grab this sine function graph and you horizontally shift it to the left by pi over 2 radian, that is 90 degrees, you will get another shape. So it's going to look like this. I think you can imagine how it's going to look like. Let me draw it better. So it's going to come here. So it's going to look like this. So see this arc on the right, the red arc. I'm just shifting this arc pi over 2 units, that is 90 degrees, to the left. That's all I'm doing. and I do this for the whole graph. So then, in that case, the graph would look like something like this, okay? The green graph. So shifting it this way, and here we're going to have minimum. Here we're going to have like this. Every single part of the graph is horizontally being shifted to the right, so sorry, to the left by 90 degrees, or pi over 2 radian. So that's what I'm doing right now. And I end up with the graph of another sinusoidal function that you can guess what the equation is. It's not y equals sine x. This time it is y equals cosine of x. So if you sit down and grab a table of values and sit down and punch in the angles again and calculate the y values, this time by pressing the cosine button on the calculator, you get different values. When you plot them, you end up with this graph, the green graph, which is the graph of cosine of x. So what you see in red is the graph of sine function. What you see in green is the graph of cosine function. Do you think the amplitude of cosine function does change? The answer is no. Period changes? No. Period doesn't change, because the cycle keeps repeating over and over again. Max value doesn't change. Mean value, the same thing. Equation of axis of the curve, same thing. Domain, same thing. Range is same thing. So even cosine function fluctuates between 1 and -1. X-intercepts, naturally, they change, of course, because before it was 0, pi, 2 pi, 3 pi, 4 pi. But now, because you shift them horizontally to the left by pi over 2, now it becomes 1 pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, 1, 3, 5, 7, odd numbers. So it's the odd multiples of pi over 2, basically. So if I write the x-intercept here as k pi for cosine, I should say 2k plus 1, which is representing an odd number in mathematics, pi over 2, okay? So 2k plus 1, or it could even be minus 1. It doesn't matter, because 2k plus 1 and 2k minus 1 in mathematics represent odd numbers for different values of k as an integer. And k is just an integer, 1, 2, 3, 4. It could be negative, it could be positive. So those are the formulas that generate the x-intercepts of sine and cosine function. Y-intercept for the cosine is of course 1. So for sine equals 0, but for cosine it is 1. It's right there, you see that. I think these are all the properties of sinusoidal functions, sine and cos. Now, when you divide sine by cos, you end up with tangent of x. I think you might have heard, or you know about this identity, tan of x equals sine x over cos x, okay? So if you grab the table of values, either punch in tangent or divide the x values by, divide the values of sine by the values of the cosine for different angles that you select, you will find basically the tangent values of those angles. And when you do that, I think you may guess what will happen, because this denominator cos x is 0 at pi over 2, it's 0 at 3 pi over 2, it's 0 at 5 pi over 2, it's 0 at 7 pi over 2. There's millions of points where cosine in the denominator is 0. And if it is 0, we can't divide a number by 0 because it's going to be undefined, right? So that's why when you draw the graph of tangent of x, wherever you have an x-intercept for the cosine function, you are going to end up with a vertical asymptote. And vertical asymptote is a vertical line that the graph approaches but never touches the value of y. On the left-hand side of this vertical asymptote is like approaching positive infinity. On the right-hand side, it approaches negative infinity. If you punch in like tangent of 89.9999 degrees, you will get a very big answer on the screen of your calculator, which shows that the graph, goes towards positive infinity. The numerator, if it's 0, sine of x is 0, that is okay. So wherever the numerator is 0, tangent will be 0. Therefore, you see that 0, 1 pi, 2 pi, -1 pi, -2 pi, wherever sine was 0, tangent is also 0. So that means that the same formula k pi can be used for x-intercepts of tangent. So for the tangent, we can say that the x-intercepts are, again, x equals k pi, just like sine x, because sine x is in the numerator for tangent function. But if the denominator is 0, then the function is undefined, and tangent of 90 degrees is undefined. Even if you check it with your calculator right now, you're punching tangent of 90, tangent of 270 degrees, you will see you get all this error message on the screen of the calculator, meaning that tangent of 90 degree angle is undefined. And these vertical asymptotes, so vertical asymptote, these vertical asymptotes have equations in the form of odd multiples of pi over 2. Same formula that we come up with for the x-intercepts of the cosine function, which are the roots of the denominator here, actually. So 2k either plus or minus 1 times pi over 2. These are the equations of the vertical asymptotes, okay? And there's infinite number of them. And again, the shape, you may see that it keeps repeating itself. Now, from negative pi over 2 to pi over 2, this is one cycle of the tangent function, and that is pi units. So the period of this function is pi units. The length of one cycle is not 2 pi, like sine and cosine function. It's just 1 pi. The amplitude, it doesn't have any amplitude. Max value, it doesn't have max value. It's like positive infinity. It doesn't have minimum value. Axis of the curve, it doesn't have axis of the curve either. Domain, it could be all real numbers except wherever we have the vertical asymptotes. So for the domain, you can say x belongs to the real numbers, but x cannot equal to 2k plus minus 1 pi over 2. So that would be the domain for the tangent function. Range would be also the real numbers, because they stretch from negative infinity at the bottom going to positive infinity at the top. And x-intercepts are the same as x-intercepts of the sine function, x equals k pi. And y-intercept will be just 0 because it is passing through the origin. So this was a quick description of trigonometric functions, sine, cos, tan. And then we have these reciprocal functions as well. And we're going to learn those basic graphs as well. Thank you.